Hey everyone, how are you? Welcome to the full course on Pandas library, and this is not just a crash course, but this is an end-to-end tutorial which is going to cover every fundamentals, a lot of real-world datasets and projects for Pandas. First of all, I am going to give you a structured roadmap that is going to balance your theoretical concept, your coding and projects you need to create for Pandas. After watching this Pandas course, you are going to turn from a beginner to a pro in Pandas. So first of all, let me tell you what are the things which we are going to cover in this particular course. First of all, I am going to introduce you to what is Pandas and why is it important for different fields like data science, machine learning, finance, business analytics. Then we are going to do the installation and setup part using Jupyter Notebook. Then we are going to import Pandas and check the version so that we verify that the installation and setup is done perfectly. Next is we are going to learn about some Pandas basics using a very small CSV dataset like students Marks Dataset. We are going to understand about the basics of Pandas where we are going to see series, data frame, reading your data, inspecting your data, selecting your columns and rows, indexing and setting indexes for your data, data types and conversions. So a lot of basics we are going to cover, and then we are going to go in the next process, which is the data cleaning and pre-processing. For this, we are going to use a real world dataset, Netflix movies dataset, to understand about some cleaning and pre-processing part of data. So whenever we perform any kind of data analysis, we first need to clean and pre-process our data, right? So these are the things which we are going to cover: handling your missing values, handling duplicate values, renaming your columns, string operations like cleaning any text columns, converting your data types into numerics or date time, basically converting the data types, converting a particular column of a particular data type into some other, detecting and handling outliers. So a lot of things we are going to cover. Then we are going to understand about data exploration and analysis. Once you have a clean data, we are going to do some exploration on our data, do some analysis on our data. We are going to filter the rows with conditions. We are going to see how we can sort our data. We are going to see how to filter our data, how to sort the data, group our data using the pivot tables and cross tabs, value counts and proportions, correlation matrix. Then we are going to understand about data visualization with Pandas. Although Pandas is not the best library for data visualization, the best libraries are Matplotlib and Seaborn. Still, we can combine Pandas with these libraries like Matplotlib and Seaborn to draw some insightful visualizations using line plot, bar plot, histogram, and a lot of different plots. Then we are going to see some advanced Pandas part where we are going to explore time series datasets, where we are going to see merging and joining data frames, multi-indexing, reshaping your data, time series analysis using the apply and lambda and map functions, vectorization and loops. Then finally, after we understand a lot of different things about Pandas, how can we use it? Now we are going to create some real world projects. We are going to do some exploratory data analysis on Titanic Dataset, and our goal will be to understand who survived, what's the relationship between age, gender, class, and survival. We are going to cover cleaning your data, then EDA, which is exploratory data analysis. Once you have a data, you explore your data, you analyze your data. Then we are going to see the visualization, and then we are going to create some insights from the data. Next is we are going to see the project number 2, which is Netflix movies dataset. We are going to find a lot of different things like most popular genres, longest movies, trends by release years. We are going to use pivot tables and group by for insights. Then we are going to do some stock market analysis. We are going to go into the finance part. We are going to utilize some data set, some stock prices data set, and do the time series analysis, moving averages, monthly returns, and volatility. Then we are going to analyze about COVID-19 dataset. We are going to seek some case trends over time, top 10 countries by cases and deaths, and this is going to be visualization heavy. That is, there will be a lot of visualizations. Then the project number 5 will be sales dataset. We are going to see which product sells the most, what's the best sales month, some customer insights. So a lot of things we are going to do. And then finally, a short session of what are the best practices and what are the next steps which you should take to advance yourself into the data analysis knowledge. So basically throughout the course, we are going to use a lot of different data sources like Titanic data, Netflix movies data, COVID-19 data, stock prices, sales data, world population data sets. So a lot of different data sets we are going to see and analyze. So first of all, let us try to understand what is Pandas. I know a lot of you guys already know about it, but let us start from the beginning. Let's make sure that even if you are a beginner, you are able to understand everything deeply. Pandas is a Python library, but it's a very special library that can do data manipulation and analysis. If you have some sort of data which Pandas can understand, it can manipulate your data and it can do some analysis on your data. So using this, you can perform data analysis. It is built on top of NumPy. So NumPy is another Python library which is used for mathematical operations, but it is very advanced. And this Pandas library, which is used for numerical operations, but it is very advanced library. And this library is used to create Pandas. Basically, Pandas is built on top of NumPy. So you will see a lot of similarity between how you use NumPy and Pandas. So if you know about NumPy, it is good. But if you do not know about NumPy, no worries. We are going to cover Pandas in such a way that you are going to understand everything about Pandas. Pandas provides an easy to use structures. Basically, when you have some data, we can store our data in some form and then we can do the manipulation and analysis over it. Pandas provides series and data frame, two very special data types which can be used to store different types of data. If you have a one-dimensional column-like data, you can use series. If you have a two-dimensional Excel-like data or SQL table-like data, you can use data frame. Pandas is used in data science for pre-processing and analyzing your data, also for visualization. When integrated with Matplotlib, it is used for machine learning pipelines. So when you have machine learning pipeline to perform a certain task, certain machine learning task, pre-processing your data is very important. Analyzing your data is very important. Cleaning your data is very important. All these things can be done using Pandas, so it is a part of your machine learning pipeline. It can be used in finance for time series analysis and stock analysis. It can understand data over time. It can understand your stock, and then it can provide you some insightful results. So you can see that Pandas is useful in lots and lots of different places, right? So now let us move on the installation and setup part for Pandas. So what I will ask you guys is, you can open your terminal and let's get started for installation and setup of Pandas. First of all, I will suggest you that you should already have Python installed. So now you need to open your terminal, and using the terminal, we are going to install Pandas, Jupyter Notebook, do the setup and start our coding. You should know that Pandas is a library which is built over Python, or it is a Python library, right? So you need to have Python already installed in your system. So how can we verify this? We can say Python -- version. Once you hit enter, we can see that Python version is 3.13. You might have 3.14, 3.12 or 3.11, 3.10, but still it is fine. If you have a Python version over 3.6 or 3.8, it is good. Now once you know that Python is already installed, let's clear the console and let us now install Pandas. For that we need to say pip install Pandas. Hit enter, wait for some time, it is going to do the installation. For me it is saying that requirement already satisfied, because for me Pandas is already installed. For you it might take some time and do the installation. Once the installation is done, let's clear the screen, and we are going to verify about Pandas installation, but let's also install one more module, which is Notebook, Jupyter Notebook, which is a browser based IDE on which we are going to do our coding. For that we can say pip install Notebook. Hit enter, wait for some time. Again, for me it is already installed, so you can see it is requirement already satisfied, which is fine. For you it might take some time and the installation should be done. Once you have installed Pandas and Notebook both, and before you open the Jupyter Notebook, I will suggest you that your terminal should point to that folder in which you want to create all your programs and all your code. So right now I am in the folder Pandas Learning, and I want to create all my code in this folder. And you can find the GitHub link of this folder in the description of this video. So you can find all the code and all the materials of this particular course on GitHub as well, which is completely free to use. Once I am on the correct folder in which I want to create my projects and my code, what I can do is I can say Python space -m space notebook. Hit enter, wait for some time, and it is going to open Jupyter Notebook for you. Now you can minimize your terminal. Don't close your terminal, just minimize this, because we are actually running a local server. Jupyter Notebook is actually running a local server, and we need to code everything on the browser. So just minimize your terminal and now come back to your browser, and you can see something like this on your browser. And the link of the browser will be localhost:8888/3. The port might be different. If this port is already in use, then the port might be different, which is fine. So now we have Pandas installed and we have Jupyter Notebook installed, and we have opened the Jupyter Notebook as well. We are going to do all the work in this particular notebook. First of all, let's first verify that the Pandas installation is completed. For that, click on this new, click on the Python 3, which is like creating a new notebook. So click on this, a new tab will open. So you are now basically creating a new notebook, and let's name this notebook as Introduction. So this is like the first step towards learning Pandas. So let's make sure that the name is Introduction. Now we need to verify that Pandas is installed successfully, right? So first of all, what you can do is you can say import Pandas, and now you can see this particular run button, which is used to run the code in a particular cell. So this is like a cell. Everything what you are writing is within a cell. So this is my cell. I want to run this cell. I will just click on this particular button, which is run. It will take some time, and once the run is complete without any error, you will see a number here, which is telling me how many run we have performed. So we have performed just one Python code run, so it is 1. So import is successful. It means that Pandas is installed in our system. You can also verify using the version. What we can do is we can say Pandas, or let's do one thing. Let's import Pandas as PD. That's a common alias for Pandas, PD. So once you update something in a cell, once you update your code in a cell, let's again run this. So point to this cell and click on this run button again. It will run, and this time you will see it is 2. It means we have run Python code 2 times, right? We don't need to worry about this number as of now. We have imported Pandas as PD. Now in another cell, let's do one thing. Let us say, let's print PD dot underscore underscore version underscore underscore. Again run the cell, and now you will see the version is 2.2.3. So we have installed Pandas version 2.2.3. So our installation is done, our setup is done. Now we are ready to code. So now let us move to our next section, which is Pandas basics. Let us understand the basics of Pandas. For this, let us continue the coding in this introduction notebook only. Now before we start working on the basics, let's have a small data set, students data set, and I have already created the data, which is called as intro.csv. So basically it's a CSV file. It means we are going to store our data in columns and rows, and it will be comma separated. So let me open this data and let me show you that it just contains few rows, 5 number of rows, and the columns are name, math, science, and English. So it's a very small data set. And how can you find this data set? You can go to the GitHub link of this project. Basically, you can find all the code of this particular course on that GitHub link. The link is in the description. So you can go there and find this data set. The name will be intro.csv. So now let us start working on the basics of Pandas. First of all, you need to understand that this is a two-dimensional data. We have rows, right? We have multiple rows and we have columns. Every column, let us just focus on one column, which is math as of now. So every column is going to store a particular data, right? Like math is going to store 85, 78, 92, 70, 88. What we can understand from here is, without me telling you, you can understand that these are the student names, these are the subjects, and these are the marks they have received, right? So basically the complete data is a two-dimensional data, and in Pandas, to store and represent a two-dimensional data, we have something called as DataFrame. And to store and understand about just one column of data, in Pandas we have something called as series. So series is a data type which is going to store one-dimensional data. DataFrame is a data type which is going to store two-dimensional data. Now you can see that this is the data which is already created. How can you create a data something like this? Let us do it first. Let us say marks is equal to, now we are going to store marks, right? If you talk about this data set, these are the marks of the students. Let us store the marks of just one subject. So now if we store the marks of just one subject, we are going to store it into something called as series, because this is just one dimensional. So first of all, let us store the marks. Let us first create a list. All right. I will tell you how can you convert this list into a series, into a Pandas series, which is basically used to store one dimensional data. So the marks can be 90, 78, 89, 10, and let us say 65. Now these are the marks a student have got in a particular subject. Let's run this code. The shortcut to run a particular code in a particular cell in Jupyter Notebook, for Mac you can use Shift Enter. For Windows you can use Control Enter or Alt Enter. You can try to use both. I think both are going to work. So I think it is Control Enter or Alt Enter. You can try this to run the code. If you're not able to run it using shortcut, you can just select, you can just focus on your cell and click on this button, run. So I'm using a MacBook, so I'm going to hit Shift Enter. If you are using a Windows, you can hit Control Enter or Alt Enter. You can try both. Now we have a marks list created. I want to convert this into a series. So I can say marks is equal to PD. PD is used to refer to Pandas. PD dot series, right? In this, I will pass my data. So this is my data, right? So let me pass this. So I will say marks is now equal to a series, and in this we are passing this particular data. Or better, what I can do is I can just cut this particular list and put it here, and I can get rid of this particular cell. I can say marks is equal to PD.series and pass my data here. This is going to create a series data type. Marks is a series data type which is used to store a particular column of data. If I just print the value of marks, then you can see we have a column of data, and the data is 90, 78, 89, 10, and 65, exactly what we have passed. And the data type for this particular data is integer 64, int 64. So this is the type of data which our marks series is storing right now. Right now you can see the indexes of your data is 0, 1, 2, 3, 4. How can you give the indexes of your data something customized? Maybe I want that the indexes should be the names of the students, right? So you can see these are the name of the students, right? I want that the indexes should be the name of these students. So I can say marks2 is equal to pd.series. So first of all, I need to pass my data, and then I need to pass the indexes. So I need to say index is equal to another data. Let me copy the marks from here, and let us say the indexes now are Alice, and then we have Bob, then we have Charlie, David, and Emma. So let me put it as Charlie, David, and Emma. So right now we are again trying to create a series, and in this series, this is our data. We have the marks of students, and the students are the indexes now. We have Alice, Bob, Charlie, David, and Emma. And now if I try to print marks 2, you will see that this time the indexes are not 0, 1, 2, 3, 4. It is Alice, Bob, Charlie, David, Emma. Now, what if I just pass 4 number of indexes and hit enter? In this case, you will see that we have the value error. That is, the length of the values are 5. It does not match the length of indexes. So we need to make sure that the number of data we have here should match the number of indexes we are trying to pass. So let me correct it. It should be Emma. Again run the code, and this is our series. Now, how can you access the data in your series? Let us see for the first series we have created, which is marks. In this, we have 5 data, 90, 78, 89, 10 and 65. We can say print marks of 0. That is, we are using the index to access our data. Hit enter and you will see at the index number 0, the value is 90. You can get the value as 90. But what about the second series, marks 2? If you talk about the marks 2, let us try to print for marks 2. And let us say the index is now ls. This because we have changed the index. So you can see it is a key error. And this should be marks 2 and run the code and you will see that the value is 90 and 90. So basically a series is a one-dimensional labeled array like one column of a spreadsheet or a Excel. So this complete one column is a series and its indexes can be labeled as well, right? So now we know about series. How about data frame? A series is just representing one column. A data frame is representing a two-dimensional data. So basically our whole data right now, what you can see on the screen, can be represented by a data frame. So a data frame is like a two-dimensional table, like an Excel sheet or a SQL table. Let's first create a data. So we are going to first create a data which is going to be a dictionary. Our dictionary is going to have keys and values. Our keys are going to be the names of the columns. So we have name, math, science and English. So let's create the columns we have. We have name, then we have something called as math, then we have something called as science, then we have something called as English. So I think these are the 4 columns, right? Now each column is storing some values, right? What they are basically storing is a series data. As of now, we can pass a list. So let's pass the list. Let us say the names are, we can copy the names from here. These are the names. What's the marks in maths? So let's copy the marks from here. These are the marks in maths. What about the marks in science? So let's store the marks in science. Let us say it is 90, 76, 89, 72 and 95. So I can say 90, 82. I can say anything, right? 79, 90 and 81. And then for English, let us say it is 86, then 72, then 89, then 90 and then 95. So basically what we are doing is we are saying we have 5 names, Alice, Bob, Charlie, David and Emma. We have 5 marks in maths, which is 90, 78, 89, 10 and 65. These are for different students. Similarly, for science, we have the marks for different students. For English, we have marks for different students. We have a data, which is a dictionary as of now. Let's convert this to a data frame. So we can say data frame df is equal to pd.dataframe. Pass your data. And let's print the df as well. Run the code and you will get something like this. Now this looks good, right? First of all, you need to understand that when you are passing a data for series, it has to be a list because it is one dimensional. But when you are passing a data for your data frame, it should be something like a dictionary because it is two dimensional. All your keys are going to be different columns and all your values are going to be filled as rows of data. So we can see we have 5 names, then we have 5 maths marks, then we have 5 marks in science, 5 marks in English. So we have converted our data to a data frame, which is a two-dimensional data. This is how we store data in Pandas. So once you have a series or a data frame created, the series and data frame data types are very powerful. We can perform a lot of powerful operations on these two data types. Now, right now we are trying to manually create our data, right? What if we already have a data? We already have a data intro.csv, right, which contains students marks. How can we read an existing data? For that, we can say, let us say df2 is equal to pd, that's the pandas dot read underscore csv. This is the function in Pandas using which we can read a CSV file. Where is the CSV file? Right now, if I come to the home folder, I can see we are right now working in the introduction notebook, right? And our data is intro.csv. Both are in the same folder. So I can just write the name of my file, which is intro.csv. Basically, I need to write the path of my file since I'm working in the same file in which my data is. So I just need to write the file name and it is going to recognize it. So we can say pd.readcsv, pass our file name, and then let's print the value of df2. And now let's run the code. Once you run the code, you will see that the data which you get here is almost similar to this particular data which we manually created, right? So now we are able to read our data and you can see Pandas data frame is very smart. It is able to recognize that the top row of your CSV file is the column names. So it has put it as the column names and then every row is your data. So it has recognized your data as well, right? And it is printing your data in a very beautiful and readable way as well. So now we are able to read our data. Now let us say you have your data in some other format. Let us say you have your data in JSON or you have your data in Excel format. So what you can do is you can use the pd dot to read an Excel data. You can use pd dot read underscore Excel function and pass your Excel data here or Excel file path. Or if you have data in a JSON format and you want to read this, you can say pd dot read underscore JSON and you can pass your data here. So this is how you can read your Excel data, your JSON data, your CSV data, and this is not limited to CSV, Excel or JSON. You can read a lot of different types of data using Pandas. But for now, let us stick to CSV to understand and focus on Pandas. Reading the data is going to be just one part. Once you are able to read the data and your data is converted into a data frame, everything is going to be same. Whether you have read your data from a CSV, from an Excel, from a JSON, it will not matter later on. Now let us try to inspect our data. Let us try to understand about our data. If we see our data frame 2, which we got from reading our intro.csv file, we got our data here as a data frame, right? First of all, let me show you a function df2 dot, basically this is the data frame dot head. If you call this function, you will get a data in return something like this. What this function does is it is going to return you the top 5 data in your data set. Basically, whatever top 5 data we have in our data frame, we are going to get it returned, and it is going to format it in a very readable manner. So you can see the names, the marks in maths, science and English for different students, right? Using this, you can get your top 5 data. But what if you want top 3 data, or what if you want top 2 data or top 10 data? We can still use the same function, which is df.head, but this time we need to pass a value. How many data do you need? I need top 3 data. I will say 3. So by default it is 5, so you don't need to pass 5. But if you just want top 3 data, you are going to say df2.head 3. Run the code and you will see that we are now getting top 3 data. What about if you want the bottom 2 data or bottom 3 data? For that you can say df2.tail. Again, if you run it without some argument, you are going to get the last 5 data. Since we have just 5 data in our data set, the top 5 and the last 5 will be same. But if we try to see the last 3 data, we can say df2.tail, and in this we need to pass 3. Hit enter, and now you will see that we are getting the last 3 data of our data set. So this is how you can get the top datas, top and bottom datas in your data set or data frame. Now how can you get the shape of your data? That is, how many rows and how many columns are there in your data? As of now, we know that we have 4 columns and 5 rows, right? But what if your data is big? How can you get the values? You can say df2 your data frame dot shape. Run the code and you will see it is 5,4. It means it has 5 rows and 4 columns. So basically it is going to return rows and columns. Now what if I just want the column names? I just want to know about name, math, science, English, just the columns. So I can say df2 dot columns and run the code, and you will see that these are the indexes, or basically the columns of your data, which is name, math, science and English. So from here you can realize that data frame is actually a very powerful data type. It has a lot of different functionalities and we have just started to explore it. Once you read a data as a data frame, you can do tons of different tasks, and we are going to do lots and lots of things in this particular course. Now there is another function which is called info. So let's call it df2.info, and you have to realize that head and tail are functions, but shape and columns are attributes. So you don't need to call them like a function, you need to call them like an attribute, right? But info is a function. Once you hit this function, you will get a lot of different details about your data. So the first information is that it is of data frame type. The class is data frame, which is in the pandas library.co.frame.dataframe. The range index is 5. It means it has 5 rows. The entries are from 0 to 4. That is, the first row is 0 and the last row is 4. There are total 4 columns. What are the columns? Name, math, science and English. How many non-null data we have? The non-null count, how many data we have which is not null. So if you see in your data, we have no null data, right? We have all the data already filled. We don't have any null data. So we are getting it as 5 non-null, 5 non-null, 5 non-null and 5 non-null. It means we have 5 data and all the 5 data are non-null. They already have a value. The data type also we are getting. The name is of object data type. Other columns are of integer 64 data types. As a summary, you can see we have 3 integer data types, 1 object data type, and the total memory usage is around 292 bytes. So we are getting a lot of good information from this particular info function, right? Now there is another function which is going to give us statistical data, which is df2.describe. Run the code and you will see a lots of data, and we are going to get statistical data, numerical data. So this will only return values for numerical columns. So we have a column name which is not numerical, it is of object data type. We have names there, right? Strings. But for other columns we have numbers. So we are getting a lot of different statistics about it. We can see that count is 5 for all the 3 subjects. The average is around 82.6 marks for math, 84.4 for science, 85.4 for English. The standard deviation we can get, what's the minimum marks, what's the first quartile data, what's the median data, what's the third quartile data, and what's the maximum data. So we are getting a lot of different information, right? So we can use this describe function. Now next is, let us see how can we select columns and rows. So we have 4 columns and 5 rows, right? How can we select a particular column? Let me show you one thing first. If I see the type of df2, you will see it is of data frame, right? But if I select a particular column, let us say I want to select the column math. So I can say df2 and I can pass my column name. It is math, right? Run the code, and now we have a math variable. And if you see the type of math, you will see that it is basically a series. And if you see the value of math, it is nothing but the math column of your data frame 2. We have this particular data frame. This is our maths column, right? This complete column itself is just a series. The whole data set is a data frame. Just one column is a series. And that you can see here. Type of math is series. And this is how you can select a particular column. But what if I want to select two columns? Let us say I want to select two columns, and the columns are science and English. So I can say multi-column, multi_column is equal to df2, and what should I pass to select two columns? I need to pass two names. I need to pass a list. Earlier I passed a string. It means I just need one column. What is that column? It is math. What if I pass a list? The first value is going to be science and the second value is going to be English. And now let me actually print the value of multi-column as well. So multi_column, and run the code, and you will see that we are getting two columns. We are getting science and English. And this time, if you will see the type of multi-column, you will see that it is data frame, because we are selecting two columns. So now it is not a series, but this can only be a data frame. A data frame is something which is two-dimensional. So we can select one column and we can select multiple columns as well. If I show you the data again, you can see that we have rows and we have columns, right? How can you select your data using rows? That is, we have rows like 0, 1, 2, 3, 4. These are the rows, right? I am trying to select my data using column names. What if I want to select using rows? So let me show you one way of doing it. I can say df2, and then I can say dot ILOC, index location. And now I can say 0. I can pass 0, and you will see that what I am getting is a row. The row has 4 data. The name is Alice, math is 85, science is 90, and English is 88. The name is 0, and the data type is object. If I say 1, I am going to get the second row. If I say 2, I am going to get the third row. Basically, the third row is going to be the second index, right? Because the index starts from 0. If I try with 5, then I should get an error, which is index error, because our index is out of bound. We just have 4 indexes, right? But this is how we can select a particular row of data from a data frame. Whatever is my data frame, I can say .iloc, which is index location, and I want this particular index of data. But this is how we can select one row. And if you want to see the type of this data, this is going to be a series, because we are just having one row. If it is just one row, one column, it is a series. What if I want to select multiple rows? I can again use the iloc, and this is not a function. Here you will see that we are not calling it using brackets. We are calling it using square braces, right? So this is like an attribute. And now let us see how we can select multiple rows. Let us say we have to select the row index 1, the row index 2, and row index 3. So we can say df2, and this time we can say .iloc. Again, we have to call iloc, and let us say 1:4. 1:4 means we have to select row with index 1, index 2, index 3. If 1 is included, 4 is excluded. Now run the code, and you will see that this is the output: Bob, Charlie, and David. And you will see it is Bob, Charlie, and David are row index 1, row index 2, row index 3. So this is how you can select multiple rows or multiple columns. But here what we are doing is we are either selecting the complete rows or we are selecting complete columns, right? What if I just want to select specific data in row and column both? That is, let us say if the data is df2, which is this one, and I just want to select the name and maths marks for row index 1 and row index 2. If I just want to select two columns, and also I want to select two rows, not all the data. Let's see how we can do it. First of all, let me show you something about .loc. This is different from ILOC. ILOC is index location. LOC is label based location. If I just pass 0 in this, you will see that what we are getting is the 0th row, right? What if I say df2.loc, that is select my data label based or using labels, and the labels are from 0 to 2. And this time you will see that we are getting all the data in row number 0, row number 1, and row number 2. But what if I just want the name and math? What I can actually do is I can say comma, in the LOC only, we can say comma, the first part is going to select the rows, the second part is going to select the columns. If I just pass one column name, let us say it is name, and run the code, what we are just getting is the names of all those students which are in row number 0, row number 1, and row number 2. If you go to this data, this is my row number 0, then 1, then 2. The names are Alice, Bob, and Charlie. We are selecting just Alice, Bob, and Charlie, right? So here we have selected few rows and few columns. What if I want multiple rows and multiple columns? So I can just copy the same code and I can say, let me pass the column names as a list, right? If I pass it as a list, what you will get is a data frame. Now I can add more column names. I can say English. So basically I just want the marks of students who are at the row number 0, row number 1, and row number 2, and just the English marks and their names. I don't want their maths and science marks. And now you can see we are able to select just the name and English columns for specific students only. So a small tip will be, we have two things. First is iLoc, which is index based location, and second is LOC, which is label based location. Now let us focus on our next part, which is indexing and setting the index. As of now, if I say print df2.index, as of now you don't know about index, right? You know about columns. We know that these are the column names of our data. This is our data and this is the column names. But what about index? You can see the index is a range index. Starting from 0 stops at 5 and step is 1. It means we have row indexes as 0, 1, 2, 3, 4. At 5 we are going to stop, so we are not going to add it. And you know what is the use of indexes? Indexes are used to identify a particular data, right? Or a particular row. But what if we want to set a particular column as our index for the data? Right now in my raw CSV file, the raw intro.csv file, I don't have something called as 1, 2, 3, 4, 5. But it is automatically adding this as an index for my data. What if in my data I already have something like serial number or roll number, which is unique, right? Which is already sorted. Roll numbers are from 1, 2, 3, 4, 5 to let us say 100 or 200 depending upon the number of students. But what if I already have that indexes? I want to use my particular column as the index for my data. What I can do is I can say df2.set_index and let's pass the column name. Let's pass the name as name. I want to set this as my index. So now you will see that the name is Alice, Bob, Charlie, David, Emma is looking a bit different from other columns because now this is an index for my data. Earlier when I was printing it, the indexes were 0, 1, 2, 3, 4. These were automatically assigned by Pandas, but right now the index is name. But the thing is, this does not change anything on df2. It is going to return a new data frame exactly like the df2, but it will set the name as the index. df2 will remain unchanged. What if I want to change df2? How can I prove it? I can say df2 and run this and you will see that still we have indexes as 0, 1, 2, 3, 4. I want that when I set the index name, I want to make sure that my data frame is affected. My original data frame is changing. So I can pass one more argument, which is in place is equal to true. I want to change it df2 only. I don't want to return a new data. I don't want to return a new data frame. I want to change my existing data frame. Run this and this time you will not see any output. And now if I run this particular cell again, you will see that the name is set as the index now. And now let's get back to this particular method of accessing our data. If I just copy the same code where I'm trying to get first 3 data or my data from row number 0 to row number 2 and only 2 columns, name and English, let us see what will happen if I just try to run the same code again. You will see the error name not in index. Because right now what we are doing is, if we come back to the code, you can see that we are trying to get our data using label based. We are trying to fetch some part of our data using label based locations. The first part is the row, the second part is the column, right? Column is fine as of now. If I just say English and English comma, let us say maths, this is fine because we have English and math. But now the rows are not 0 or 1 or 2. These are the names: Alice, Bob, Charlie, David and Emma. So now instead of this, if I pass for the row part, if I say Alice and now I run the code and you will see the data here. For Alice, the marks in English is 88, marks in math is 85. It is 85 and 88, right? I can say Alice colon Bob. And this time I'm going to get data from Alice to Bob, right? You can see Alice and Bob both are included. So when we are using this method, Alice and Bob both are going to be included. I can say from Alice to David. So I can say Alice colon David and I will get the data from Alice to David and the marks for maths and English. So this is how you can fetch your data using iLoc and loc. If I use iLoc instead of loc, you will see that iLoc requires numeric indexes. It got English and math. Now let us focus on the data types and data conversions. Now right now we have seen 2 different types of data in Pandas. We have every column as a series and we have the complete data, the 2-dimensional data as a data frame. Now every data in your column is storing some value, right? It can be integer, it can be float, it can be strings, right? So basically we have different data types inside our data itself, right? We can have numerical data, string data, Boolean data, right? So we have a lot of different data which is possible. So now let us analyze the data types of our actual data. If I right now say df2.dtypes and hit and run the code, you will see that the data type of math is int64, science is int64 and English is int64. Okay, so we are not getting it for name because name is not treated as a column now, it is treated as a index. So let's actually do one thing. Let's reset the index, and how we can do it? Let's get rid of the index name. Let's make sure that the original indexes 0, 1, 2, 3, 4 be our indexes. So we can say df2.reset_index and don't forget to add in place is equal to true. Run the code, and now if I run this df2.datatypes again, you will see that name is also included here. So we are getting the name as object. It means we are trying to store the data of object type. Object is basically the base data type of all other data types. But math, science, and English, they are storing numerical values of integer type, int64 types. Now, what if I want to convert my math data type from int64 to float? That is, from a numerical or integral data, I want to convert it to a decimal data. Because marks can be in decimal, right? Somebody can get 35.5 marks or 45.5 marks. So let's convert it from integer to float. And how can we do it? We can say df2, and how can we select a particular column? We can just pass the column name. We can say math, right? This is how we are selecting our data or a particular column, right? We can say this is equal to df2 math. Again, select your data, and this time call a function dot as type. And in this, you need to pass your data type in which you want to convert your current data to. I want to convert it to float. I want to convert my math column to a float data type. Let's run the code, and now if I just run this particular part again, df2.datatypes, you will see that math is now float 64. Even if I show you the data, you will see that the math is 85.0, 78.0, 92.0, right? It is not an integer now. It is a decimal now. So this is how you can convert one data type to another data type. Let us add one more column in our data. How can we do it? What we can do is we can say exam date is equal to a list. Let's create an exam date column, and let's make the values in this column as 2025-03-01, basically 1st of March, and let's multiply it with df2.shape of 0. Now you tell me what I am trying to do here. If I print the value of exam date here, what you will get as an output is a list in which you have 1, 2, 3, 4, 5 values, and all the values are same. Basically, if you see, the shape is 5 by 4 or 5 comma 4. If I'm selecting the first or 0th value or the 0th index value, it is selecting the number of rows in my data. I want to create another column named as exam date in my data, the data frame 2, and I want to fill the values as 1st of March for all the rows. So I created my value now. So I created a list now. Now what I can do is I can convert this into a series, right? Basically, every column is a series. So let me create a series. I can say exam date underscore series is equal to pd dot series, and I can pass my exam date in this, right? I got a series now. Now I can say df2. As of now, the df2 is this one. It has 4 columns, 5 rows. But I can say df2, let's create another column, exam date, and let us say this is equal to exam date underscore series. Run the code, and now let us see the value of df2. This will have one more column, exam date, and the values are going to be 1st of March 2025 for all the rows, right? If I again see the data types of all the columns, you will notice that the data type of exam date is object. How can I convert it to a date time? Because this has to be a date time, right? To convert the exam date column to a date time column, we can use a function of pandas, and I will show you what. We can say df2, which is our data frame name, and the exam date, which is our column name, and run the code. You will see this is our current data, and the data type is object. We can say this is equal to pd.to underscore date time. There is a function in pandas which can convert your data to a date time. This time you don't need to use this as type. You need to use pd.to date time. We want to convert our data to date time, and which is our data? The data is, let us select the existing data, which is again df2 exam date, right? This is our existing data which we want to convert to a date time. If I just run this code, and now if I see the value of df2.dtypes, you will see that the exam date is now of date time 64. If I print the value of df2, you won't see any change, but in the data types, you can definitely see the exam date is now of date time type. So now if I say df2.info, you will see that we have exam date as date time 64, English as int 64, science as int 64, math as float 64, name as object. We have 5 entries in our data, and we have total 5 columns. So we have a one column which is of data type date 64, one column which is of data type float 64. We have 2 columns of data type int64 and 1 column of data type object. The total memory usage is now 332 bytes. So we are done with the basics of pandas. Now we are going to deal with data cleaning and data pre-processing part, and we are going to use the Netflix movies dataset for this. Now you can download this dataset from the project folder which I have shared as a GitHub link in the description of this video. You can go to the GitHub link and get all the project files. In that project files, you will see this Netflix underscore titles file, which is the Netflix movies dataset which we are going to use for our data cleaning and pre-processing part. So you can go to the GitHub link, get the data from there, and then we can continue together. For this, let me close this existing notebook, which is the introduction. We are good with the introduction now. Let's do the pre-processing part. So we can open another terminal. So you can go to the home page of your Jupyter notebook and open another Python notebook, which is by clicking this new, then Python 3. It will open another notebook and you can name this notebook as cleaning and pre-processing. First of all, what we always have to do is we have to import pandas as PD and then we have to read our data. Let me first open this Netflix underscore titles file and you will see that this is our Netflix movies dataset we have. We have a big dataset and we will perform cleaning and pre-processing of this dataset. So first of all, we need to load this dataset as a data frame. Why? Because this is a two-dimensional data, right? It has columns and it has rows. Now let me load this two-dimensional data as a data frame. So for this, what we can do is we can say data is equal to pd.read underscore CSV, because we are reading our data from a CSV file and the CSV file name is Netflix underscore titles. So it is Netflix underscore titles.csv. Run the code and now we are able to read our data. We are not passing the complete path of our file and the reason is right now our cleaning and pre-processing file is in the same folder as the CSV data we have, which is Netflix underscore titles.csv. So we just need to pass the file name and that should do it. First of all, before starting any cleaning and pre-processing, let us see some basics of our data, some statistics of our data. Let us see the top 5 data of our Netflix movies dataset. So we can say data, which is the data frame. If I see the type of data, it should be data frame. And if I say data.head, this is going to return the top 5 data. Run the code and you will see the top 5 data in your dataset. You can see we have show ID, type, title, director, cast, and a lot of different columns. And we have multiple rows. We have 5 rows. Also, let us see the bottom 5 data. So we can say data.tail, right? So this is how you can see the bottom 5 data. Now let us see the shape of our data. How many columns and how many rows do we have? So we can say data.shape. Run the code and you will see that we have around 8,807 rows, 12 columns. And now let us see some information about our data. These are very important steps when you have to perform cleaning and pre-processing of your data. And why cleaning and pre-processing is very important? Because your data can be dirty, your data can be incomplete, your data can contain errors. Before you actually use this data for any machine learning model, you have to make sure that it is clean and pre-processed in such a format that it can be used for your model or for analysis as well. So I can say data.info to get some information about my data, and what I get to see is I have around 8,807 rows, 12 columns. These are my columns and almost all the columns, I think 12 columns we have and almost 11 columns are of object data type. We have release year, which is an integer data type, right? Also what we can get is non-null count. I expect that we should not have any null data in our columns, but we have 8,807 entries, but we have few columns which are incomplete or null. We can see that show ID is fine, type is fine, and title is fine. All have 8,807 non-null values, but director has 6,173 non-null values. It has almost 2,600 null values. Similarly, cast is also not having the complete number of rows as non-null. So from here we can identify that we have director, we have cast, we have country, we have date added as well. We have something missing in the rating as well. They are not having the value as 8807. That should be the number of non-null count, but it is not for few columns. So from here we identify that yes, we have to do some cleaning and pre-processing, right? It used around 825.8 plus KB of data. Alright, so now we have some information about our data. Let us see what are the columns we have. So we can say data.columns and hit enter and run the code, and you will see that these are the columns we have. Now first of all, let us analyze the null values. Now we are going to handle the missing values, handle missing values. We can say data dot is null, right? First of all, if you run this function is null, what it is going to return is, it is going to return you the exact data what you have, 8,807 rows and 12 columns. Values are just going to be true or false. It is going to be true if the data here is null. It is going to be false if the data here is non-null. You can see that the country for index number 0 and index number 1 is false, but for 2 it is true. It means that for row number 2, country is null. Let's come back to the top 5 data we found, and if you see the country value, for row number 0, for row number 1 it is United States and South Africa, but for row number 2 it is NAN, which basically means that it is null, it is empty. If I go to my original CSV file, you can see that the country column is empty in the third row. For first row, for second row, it is United States and South Africa, but then it is empty and empty. That is what we found here. NAN, 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 NAN. It means it is null. So that is what we are getting here. Data dot is null. But this is not very informative. Who is going to see all the rows, right? I want a numerical data to understand how many null data I have per column. I can say data, that's my data frame, dot is null dot sum. Run this code and you will find that show ID is 0, type is 0, title is 0. You have no null values in these columns. Director has a lot of null values. Cast has lot of null values. Country has lot of null values. Date added has few null values. Rating and duration has few null values. Now this is a very informative data, right? Now you might have started to understand how powerful is data frame, right? It is giving us a lots and lot of information. Now one of the way to handle missing values is just delete or drop those rows which are null. For example, if this particular row has a country as null, I can say let me just get rid of it, let me just delete it. Let me delete this particular row number 4 because it has some incomplete data. It is one of the way to handle your missing values. But let us not do the change directly in our data frame. Let us do the change in a separate data frame so that our original data frame is not affected. We can say data underscore drop is equal to data dot, there is a function called as drop na. What this is going to do is it is going to drop or delete any row which is empty, which has a null value. Any row, if any column in that particular row is null, it is going to delete that particular row. If I run this particular code and now if I try to analyze the value of data drop, this is not going to do any change in data. This is actually going to do a change in a different data frame and return that data frame. That data frame is now data drop, data underscore drop. If I see the data underscore drop now, it has 5332 column. And if I try to see the data now, it still has all the rows we have. So there is no change in the data, but the change is in the data underscore drop. Let us see how many null values does data underscore drop has. So we can say data underscore drop dot is null, and then we can do the sum. Run this code and you will see that no columns are empty. No columns are having any null values. Now this is one of the way to handle missing values. What if I don't want to handle it in this way? What if I want to fill a particular value if any data is empty? We can see the director is empty for few of the rows, right? For the movie Blood and Water, the director is empty. For the TV show Blood and Water, Quota Factory, the director is empty. Now I might want to fill the values if I know the values, right? But if you will notice here, if when we run the code data.isNull.sum, we got to know that we have 2634 director data missing. Now it is very hard to fill all the values as of now. What if I want to just fill the values as unknown for all the columns, for all the rows of director which are null? So what I can do is I can say data, then let me select the column which is director. I want to do the change in this particular column, right? I can say dot fill na. Fill na is going to fill all the values in those rows of this director column which are null. I want to fill it with a value called as unknown. And I want to do the change directly in my data as well. So I can say data of this director column is now equal to data of director column dot fill na, because this is going to return a new series or a new column, right? I want to have this change directly in my data as well, right? So I can just run this code, and now if I see data dot is null dot sum, you will see that director is empty, director is 0. Now if I try to show you the value of data for director, you will see that a lot of values will be unknown. So you can see it is unknown, then it is unknown, unknown, right? So first we have Kristen Johnson, then we have unknown, then we have Julian, then we have unknown. That's what you can see here as well. We have Kristen Johnson, then empty, which is now unknown, then we have Julian, then again it is unknown. So we have filled the null values for director, right? Now what about country? We have 831 countries missing out of 800,807 data, around 10%. Now I can again fill it with some NA value, some unknown value, but that is not going to serve the purpose of this course. I am here to teach you something, right? So let's try to do it in a different way now. Let us try to understand one more way of filling the null values. I can say data, and let's select the country first, okay? We have this country data and it is empty, right? It is NaN for a lot of different rows. What I can do is let me fill the values of country which are null as that country which is the most common in my data. As of now, I have a country column in my data which has United States, South Africa, India. It has United Kingdom, United States, a lot of different values, right? Let me fill the null values with that value which is most common. I mean, this is not the best way to do it, but this is one of the way we can do it. Now, what's the most common country value? How can you find this? We can say we can first select the column, and then we can call a function which is dot mode. From here we can see that it is United States. It means United States is the most common country in my dataset. There is one more function, let me tell you that function, which is going to give you more insights about it. If I say data and then select the column and call the function value underscore counts and run this, you will see that we have United States 2818 times. Then we have India about 972 times, United Kingdom about 419 times, right? And that's what we got here as well. Data country.mode, data of country.mode is going to give you that particular value which is the most common. We can verify it from here as well. Now I just want to select the country name. So I can say most common country. This will be equal to data of country column.mode, and then we can select the 0th row. If I just print the value of most common country, it is going to be United States. I want to fill the null country values with United States, the most common country. How can we do it? The steps are going to be same as we did it for director. We just need to select our column name. We can say data, our column is country. Then I can say dot fill NA and fill the null values with most common country, and also do the change in my original data. So I can say data of country column is equal to this now, and run the code. And now again, if I say data dot is null dot sum, country will be 0. All the null values are now filled. Now we can do it in different way for cast, for release year, for rating, and all, right? For release year, it is not important because it is already fine. Now what about rating? Just few data of rating is null, right? The method which we just used, the most common one, is something we can actually use for rating. And the reason is, if we have just a few, like 0.5 or 1% of your data which is missing for a particular column, you can fill it with your most common value and it is not going to affect a lot. So for country, it was not the best way, but still we wanted to learn a new way to fill our data. So that is why I told you. But for rating, it will be the best way to do it using the most common rating. So we can say data and we can update the rating. We can say rating is equal to, let us select the data and rating column, and we can say dot fill NA, fill the null values, and we are going to select the most common value of the rating only. So we can say data of rating dot mode and select the first data or the 0th index. Hit enter or run the code, and now if I run this particular part again, data dot is null dot sum, you will see that rating is also filled. So these are few ways to fill your null values. But what about duplicate values? Let us understand about duplicate values. If I say data dot duplicated and dot sum and run the code, you will see that it is 0. So we have like no duplicate values, like none of the rows are completely duplicate. So what I mean by this is, let us say if these two rows were completely identical, then if we use this data for further pre-processing and machine learning model, then they will be same, right? Having the same data is not going to give us a lot of value. So we can drop any data which is completely duplicate. So first of all, we can calculate duplicate values in our data. If it is 0, then it is fine. But if it is not, and you want to drop all the duplicate rows, you can say that data dot drop underscore duplicates. When you run the code, it is going to drop any rows which are duplicate. But since the rows are not duplicate, it is not going to drop anything as of now for this data set, which is fine. But we know the way how to drop duplicate rows now, right? Now, how to rename your data? Now, this is very important. To have a clean data, you have to rename your data sometimes. Now, how to rename columns of your data? As of now, if we see the columns of our current data, you will see it is show ID, type, title, director, cast, country, and all, which is fine. It looks good as of now. But this listed in column, if you focus on the listed in and the values, you will see the values are documentaries, international TV shows, drama. Basically, this is the genre of our movies. But the listed in is not going to tell us a lot about this. But if we just rename the column to genre, it is going to tell a lot about this particular column, right? So how can you rename this? We can say data.rename. We are trying to rename columns. We can rename multiple columns at once. And what we can do is, in the rename, the first argument can be a dictionary in which we can pass the different column names which we want to rename. So I want to rename this listed in column, right? So my key will be the column name which I want to rename, and my value will be the data to which I want to rename it to. So I can say listed in, and then I want to rename it to genre. And let us say I also want to rename the date added column, right? So I want to rename date added, and I want to rename this to, let us say, date added. I just want to change the format of it, right? And let's do this for release year as well. So I can say, let me change the name of release year column and let me make it as release year, right? I want to do the change directly in my data, because if I just run the code as of now, it is going to return me another data frame which has these column names changed. I want to do it in my original data frame. So I can say my second argument will be comma in place is equal to true. And before we run the code, we actually need to pass the first argument as a keyword argument. So we have to say columns is equal to this dictionary. So what we are basically doing is we are saying data.rename. Let's rename the columns, and the columns which we want to rename are listed in, date added, and release year. Make it genre, date added, and release year. Do it in place. Do it directly in my original data frame. Run the code, and now if I see the value of data.columns, you will see the values are date added, release year, and genre. If I see my original data, data.head, you will see the column names are not genre, date added, and release year. Now this is much more valuable because earlier it was listed in, which was something which is not known to everyone, but genre is something which everybody knows, right? Now what if I got to have another requirement that I have to lowercase all my column names. As of now, you can see genre has a G, which is uppercase. This release year and date added has A and Y as uppercase. How can I change the name of all my columns and make it lowercase? So I can say data dot columns. This is how we can fetch the columns, right? I can also say data dot columns is equal to a list, right? This list is going to get all the values from existing data dot columns. So I can say for call in data dot columns, the values I can assign is call dot lower, right? And also we can perform any operation. We can say dot replace, let me replace any space with dash, right? If I run this, and now if I see the data dot columns, you will see the values are show id, type, title, director, cast, date added, release year, rating, duration, genre, and description. All are lowercase, right? Better what I can do is I can replace the underscore with hyphen. So I can say instead of space, let me make it as underscore. Run the code. If I again see the columns, you will see that the show id now has a hyphen. So this is going to standardize the column names, which will make it easy for coding as well and for understanding as well. Now let us see some string operations which we can perform on our data. Let us perform the first operation on the title. Let us fetch the title. We can say data and title. Let us select the title column. And these are the different titles we have, right? Let us first strip any extra spaces we could have in any movie names. For example, if I just select the 0th row, for that I selected the column, and now let me select the 0th row. It is Dick Johnson is dead, right? Now what if this could have any extra spaces in the left or right? We have these kind of data, right? If we have some movie name, like if we have the movie name as like Titanic, if your movie name as a string has any extra space in the right hand side or in the left hand side, we want to remove it, right? I don't know how many data I have which has extra spaces, but I want to remove those. How can I do it? I can say I can select the title column of my data, and I can say this is equal to data. Let's select the title column again. Can we do it directly like dot strip? No, this is going to give us an error. Strip is a string function, but coding in Pandas is very clean. We can use all string functions in a string column. We just need to say select the column, then dot str dot all the string functions which you want to use. If I just run this code, now my data dot title will be changed for all the rows. For every data, it will strip any extra spaces. So it is going to strip any extra white space from left and right for all the titles. What if I want to lowercase my data? Let's do this. Let us say if I see my data as of now, these are my data. I want to lowercase my data, right? This is something which we can see as well. So this will be equal to data, then select your title, and then dot str to access all the string functions. I can say dot lower. Run this, and now if I see the value of data title, you will see that all the values will be lowercase. Well, it is really good, right? Now what if I want to remove any unwanted characters from my data? I just want to keep alphabets or digits. If it is if my movie name has this, and I want to remove this is like a symbol, right? I want to remove these kind of symbols from my title. I can say data title, this is equal to data of title. Let's select this column. Now let us call dot str to access the string functions, and I can say dot replace, and I can perform regular expressions, regex in this as well. The regular expression to select all the characters which are not alphabets will be, we can have square braces. In this first will be a caret, this particular symbol, and then we are going to say a hyphen z, then uppercase a hyphen uppercase z, and then 0-9, and then space. We are saying that if any character is not a dash z, is not lowercase alphabet or uppercase alphabet or a digit or a space, select all those characters and replace all those characters with my second argument, which is empty. That is, remove all those characters. And now we also need to pass one more argument, which is regex is equal to true. That is, this is a regular expression and not a normal expression. If I run the code and try to see my title again, you will see that the blood and water doesn't have that ampersand, doesn't have that and symbol now. Alright, so these are some string operations we can perform on our data to clean our data. Now, let us talk about how to see what are the unique values we have. Let us select a column which is genre, right? If you see this column, it is documentaries, it is international TV shows, TV dramas, TV mysteries, a lot of different genres are assigned to a particular movie, right? How can I find the unique values which I have as a genre? So I can say select the column and call the function dot unique. If you call this function, you will see all the unique values which you have as the genre. We can do the same for rating as well. Let us see what are the different ratings which we have available. We can say, so just select the column and call the unique function. Run the code, and you can see that these are the different ratings available for a movie. It is PG-13, TVMA, PG, TV14, right? 84 main, 66 main, a lot of different ratings are there, right? But this is how you can find all the unique values which you have for a particular column. But if we talk about genres, right? You can see that the genres are documentaries, international TV shows, TV dramas. One single movie is having a lot of genres, right? Now let me show you one operation which we can perform to clean this data. We can say let's create another column in our data which is genre underscore list or hyphen list, right? And this will be equal to, let's select the genre column, and let's call a string function on this which is split. I can say .str dot split, and let's split this using comma. If you see this data, if you see any data of a genre, it is crime TV shows, comma, international TV shows, comma, TV action and adventure, right? I just want to split this into multiple data. If I just run this and try to see what's the value of this genre list, the new column which we just created, you will see that it is now like a list. Basically, it's a single column, but it's a list now. Basically, we have split the multiple genres into a list. Now let us do some data type conversions. So if I see the data types of my current data, you will see that it is object, mostly it is object, right? Just release year is integer, other are objects. But if you see the data, I don't think every data should be an object. We can say that the release year is fine, but the date added should not be an object, but should be a date time, right? So let us convert this to a date time. To convert a particular column to a date time, we have this pd.to underscore date time function, right? In this, let us pass the column name. So it will be data, and then the column name is date added, right? I think A should be lowercase, so date added. And if I just run the code, you will see that we are getting some error, right? The error is value error. Time data, August 4, 2017 doesn't match the format, right? Basically what's happening is it is trying to convert all your dates into the date time format, but some of the values are not in the format that it can convert it to a date time. So there is an argument called as errors. Errors is equal to quotes, right? Now if you run this code, you will see that all the values are now converted. Basically what's happening is the values which couldn't be converted, for those values error is not raised. For the invalid dates, it is just going to replace it with values called as NAT, which is not a time. That's Pandas version of saying null. But right now we have not done the change directly in date added column, right? It is not in place. What we can do is we can say the date added column in my data, this will now be equal to the new column which is being returned from this particular code, right? What this will do is this will first convert your data, the date added column data, to date time, and then all the errors are going to be suppressed, and then it will assign this new column value to the date added. That is, it will do the change in the data frame. So I can say data dot d types. First of all, let me run this code, and now let us see the data types, and you will see that the date added is now date time. Looks good, right? Now let us add two more columns. Let us say data, and the column name is year underscore added, and this will be equal to, we are going to fetch the value from the date added column. We can say data and date added. I want to use the date time functions, right? So I can say dot dt dot year. Also what I can do is I can say data and month underscore added. This will be equal to data and then month underscore date added. To use the date time functions, I can say dot dt dot month, and instead of underscore, let's make it as hyphen. All right, let's run the code, and now if I see my data, or better, let's see just the top 5 data. So data dot head, you will see that we have two more columns: year added, which is 2021, month added, which is ninth month, right? So and now the date added looks something like this: 2021 09 to 25. So this is how we clean our data, right? Many of the columns which are coming as a text or object can be converted, and we have converted it before the analysis actually begins, right? Now let us see one more thing. Let us see the unique values in release year. So I can say data dot data. Let us select the release year column, and let us select the unique values, and let us fetch the unique values from this particular column. So these are the unique values it has, right? Here you can see that your data is mostly from 1943 to 2020 and 21. So the data looks fine as of now, right? But just to assume that if your data would have had some outlier, some values which doesn't seem to be possible, right? Some unrealistic release years, for example, 2099. By mistake, if you have some data which has a value at 2099, how can you see this and how can you remove those values? Let us see. Let's make use of plotting. Let's make use of visualization and plotting using matplotlib. If you have matplotlib already installed, then good. If you don't have it installed, you can get it installed directly in using your Jupyter notebook only. You can just say exclamation and then pip space install space matplotlib. Run this code, and this is actually going to run a terminal command, and this is going to install matplotlib. Now once the installation is done, let me actually clear this particular part, and once the installation is done, let's import matplotlib.pyplot as plt. Let's run this code, and now let's try to plot the release years. This course is about pandas, so don't worry about the things which we are doing when doing the visualization. It's fine if you don't understand a lot of things. So let us first select the release year of your data and then say dot plot. Let us do the plotting of it. Let's plot this data, and if I just run the code as of now, it is going to show me this particular plot. Now this is not telling me a lot of things, right? But what if I change this plot? In this plot I pass an argument kind is equal to box. I want a box plot. Run the code. Now this graph is telling me that most of my movies are within this range. I think it is something around 2016. So most of my movies are in my data is in 2016 or around that. But a lot of movies which we can say that those are like outliers are released before 2000. Now let me show you one more thing before I actually try to tell you a lot about this particular graph. Let us say data and then select your column release year and call a function value underscore counts. It is going to give us the count of all the unique values in our data. So for release year, I can see that around 1000 data is in 2018, 1000 in 2017, 1000 in 2019. So what we can basically understand is this particular data, the box is actually telling me the interquartile range. That is, the middle part is 50% of my movies are within this range. I think it should be 2017. The line is the median release year. These dots below are like an outliers. These data is telling me most of my shows are released between 2000 to 2020. Most of my data is between this particular range. A very few data, I think the few old movies entries are from 1920 to 2000, right? So these data looks like outliers. They do not contribute a lot in our data, right? You can see their counts are too low, right? 1925, we have one movie from 1961, 1947. So we have some movies which are from old times, but most of our movies are within this range, right? So this is what this box is telling me, that most of my movies are within the range of 2000 to 2020. Now let us try to find out these outliers. As a box plot, this is telling me an overview of my data, but let's actually find out those outlier movies. So let's first find out the first quartile of my data, the first 25% of my data. So let's select the column data, the release year, and then say dot quantile, and in this you need to pass the value as 0.25. If you run this and see the value of Q1, it is telling me that 25% of my movies are within the range of 2013. What if I try to find out the quartile 3, the Q3 as well, right? So I can say data of release year dot quantile 0.75. And now if I print the value of Q3 as well, it is telling me 75% of my movies are within the range of 2019. 25% is within the range of 2013. 75 is 2019. It means so around 50% of my movies is from 2013 to 2019, right? If I want to find out the interquartile range, this will be Q3 minus Q1, right? So I can find the value of interquartile range, and this is 6, right? Now let me try to find out the lower interquartile range, which is lower will be equal to, now these are some mathematical formulas, so if you don't know about it, it's completely fine. Just follow along. We can say Q1 minus 1.5 times the IQR, the interquartile range. And what's the upper? It will be equal to Q3 plus 1.5 multiplied by IQR. Now if I print the value of lower and upper, you will notice something. Let me first print the value. This is 2004 and this is 2028. This lower and upper is telling me that if movies are within this range, it is fine. But if movies are outside of this range, then those are like outliers. Those contribute very less to the data. So let's find out the outliers. So I can say outliers is equal to, and what is an outlier? Outlier is a abnormal data in your data set. So although those are valid data in a huge data set where movies are mostly from 2000 to 2020, the older movies are not going to contribute a lot, right? So they are like outliers. I can say, let me select the data. To select the outliers, I want to select only those data for which the release year is less than lower or more than upper, right? So to add the condition to select data in DataFrame, we can just say whatever your DataFrame name, data, then the square braces, and inside this we can pass our condition. So our first condition is, let's say data of release year, this particular data will be less than lower, then it is an outlier. Or for or, you are not going to say or, you are going to say the pipe symbol or, and then add another condition, data, then release year again is more than upper. If I run this code, and first of all let me print the value of outliers as well, then you will see that we have around 720 outliers data. And for this data, if I just select the release year, then you will find that the values are mostly less than 2004 or more than 2028, the lower and upper bound of our data. So this is how you can find outliers. Or what I can basically do is, let's only remove those data which are unrealistic. Let us remove those data in which the release year is more than 2025, which is not possible, or less than 1920, which is possible, but let's remove it. For that, we can have a condition. We can say data, let me select only those columns for which the release year is more than or equal to 1920, or let's make it as 1930, and add one more condition that, or if the release year is less than equal to 2025, then this is valid. So these are the valid data we have, right? I think this is incomplete. Let me fill one more bracket. This is fine now. So where are we missing something? So are we missing something here? All right, so it should be a square base. So these are the data which are valid. So if I see we have 8,807 rows, right? Let's actually do one thing. Let's make sure that the release year is more than 1950. I think the condition should be and not or, because we want to only select movies for which these two conditions are true. That is, they are within this range. Or let's make it as 1950. If I run this, what you get is you get 8,791 rows. It's less than the number of rows which we had. We initially had 8,807 rows. Now we have less, right? So we have removed some unrealistic or unwanted movies, and let's actually change it directly in our data. So we can say data is equal to this. Whatever data frame is being returned, we are going to update our original data with this data frame, right? Let's run this code, and this is our data frame now. Data.head. It's good. So now what we have is a clean data, right? So now that our Netflix dataset is clean, structured, pre-processed, we can start analyzing it. When we move to the real world projects section, we are going to do the exploratory data analysis of the Netflix movies dataset as well. So our next section is data exploration and analysis. We are going to do some exploratory data analysis on our Netflix movies dataset, since it is clean now, since it is processed now, right? We already detected and we removed the missing values, we removed the duplicate entries, we renamed the columns, we performed some string operations, some type conversions, and we detected and removed the outliers as well. Now we are going to focus on the next part, which is exploratory data analysis on this Netflix movies dataset.